I find myself both surprised and also kind of not surprised at the number of certificate services infrastructures you don't see in people's infrastructures these days. I find myself surprised because the basics of a certificate services infrastructure, a Windows-based one, really easy to implement. A couple of clicks and pretty much you're done. And Microsoft's automation in deploying out the required sort of root certificates makes this process even easier. You'll find that once you get ADCS up and running, getting those root certificates deployed out is something that happens almost automatically thanks to group policy. Where I'm not surprised is that the content that surrounds ADCS, like the knowledge that you have to search through on TechNet and in other places in order to get one up and running, can be really overwhelming. There are a lot of additional pieces to ADCS beyond the basic installation that make it seem just ridiculously difficult. And that is totally warranted because today's ADCS, there's a lot to it and you can do a lot with it, and it is extremely powerful. And there can be the appearance of being easy ways to really screw it up. Now, in this nugget, I'm going to show you some of the basic, just introductory bits that are associated with ADCS. I'm going to show you a little bit more than what you need to know just for the exam, because the exam content here appears, at least it feels like it appears, to just kind of teach you on some of the vocabulary pieces. But I think you also need to know how to build an enterprise certificate authority if you're really going to appreciate that vocabulary. So we'll go just a bit further than what you need to know than for the exam, but I'll try to clue you in on stuff that at least I think you should be aware of. Now, a basic enterprise certificate authority, just a single server, as I said, easy to put together. But where a lot of people get confused is the fact that a lot of certificates in production, a lot of CAs in production, can drive you down the path of needing some overly complicated configurations that you may not need for just small implementations. A fully configured ADCS infrastructure can have up to 3 or even more ADCS servers that get laid into place. In the world's most complicated ADCS infrastructure, the whole configuration starts out with a root CA that starts up here at the top. And most typically, the root CA is an offline root CA. So once you create this root CA, you build the root CA in a work group. It's not a member of a domain. And the only thing that the root CA does is it generates one certificate that you give down to your policy CA. Your policy CA, and there can be more than one policy CAs, can either be standalone or they can be enterprise. If they're standalone, they have no integration with Active Directory. If they're enterprise, they do have integration with Active Directory. And it is the job of the policy CA not to actually issue certificates. It issues policy-oriented certificates, to use a soft term here. Its job then is to define the policy for the third level CA that we call an issuing CA. And the issuing CA is in almost every case an online enterprise CA. And what that means is that this machine is always up and operational. It's on your it's built into your infrastructure. It's powered on. By enterprise, we mean that it's a member of your domain. It's actually a domain member. And so all of your little workstations out here, and all of the servers, the web servers, and all of the other servers that are out there that need certificates are going to actually get them directly from that issuing CA. And when you hear about the trust chain and how a certificate needs to be, quote, fully trusted, when we talk about trust chains, what we're talking about is that in order for the certificates that come out of this issuing CA to actually be valid, you also have to possess the certificates for this one, and also for this CA as well. The trust chain is essentially the notion that this certificate is trusted by this certificate, which is trusted by this certificate, which is trusted by you. And because that entire chain exists and is functional and valid and not revoked, you have a full trust chain. Now, if you've never played around with an internally built Active Directory certificate services infrastructure, well, you may have actually worked with perhaps certificates that you purchased from some other entity. Maybe it was GoDaddy, or maybe it was any of the other million different certificate authorities that are out there that will sell you a certificate from anywhere from tens of dollars to hundreds or even thousands of dollars. And the important difference here, that what's mainly different between what you build inside and what you buy on the outside, is that at the top level, these root certificates, really at every level, but at the top level, the root certificates that are coming out of a GoDaddy are automatically trusted by your Windows machine, your desktops and your servers, because Microsoft has just simply inserted those root certificates directly onto the machine right as soon as it's built. So because those certificates are already on the machine, that's why it's really easy for you to go and buy a GoDaddy or any other of those certificates that are on there, because you don't have to go through the extra effort. What's awesome here is that I can show you in just a couple of clicks, in fact just here in this nugget, how you can create fully trusted certificates inside your own organization. And being inside your own organization, you can manipulate those certificates and create them for whatever types of uses you want. So, there are classic web server certificates, but there are also other types as well, like code signing certificates. We didn't used to use much of these at all in the old days, but now that we have Windows PowerShell, in order to create scripts, it's best to sign those scripts with a code signing certificate. Now, a code signing certificate can actually be relatively expensive if you try to buy one from a GoDaddy. But if you create one yourself that's automatically trusted already, it's really simple at a couple of clicks and no extra cost to build those code signing certificates. There are other uses for certificates as well, like for Hyper-V Replica that we talked about before. Hyper-V Replica requires a certain type of certificate that is not your typical web server cert. It's a special certificate that requires both the client authentication and the server authentication pieces. So these are these special kinds of certs that can actually add up over time if you're having to go back to any of these online, GoDaddy or VeriSign or whomever it is that you buy your certificates from. In this and also the next nugget on managing certs, I'm going to show you some really cool ways in which you just do all this. And I think you'll leave with a better appreciation for how you can really build this just on your own. Now, I do kind of want to show you here that the type of ADCS infrastructure we're going to build in this series is going to be a really simple one server. That server will be a root server and an issuing server. That server will be an online server. It'll be an enterprise server. So we're not going to go through the multiple steps that are required in order to put all these pieces into place that you would probably want in a production sense. If you do want to take your learning a little bit further, if you do really want to know how these things kind of work best in production, I'm going to point you to 3 other nuggets that I've put together for the 7414 series. This is the MCSE Advanced Server Infrastructure series. And then somewhere down here on the bottom, I have right here, designing a certificate services infrastructure, implementing and managing, and then implementing and managing certificates. You'll find that there's going to be some overlap between what you'll know here and what you'll learn in those 3. But if you really want to learn the gory details of creating a multi-server environment, that'll give you a better appreciation for all those different topics and maybe give you the information you need to know in order to build one in your own infrastructure. It's actually kind of fun once you start tooling around with how these different certificate infrastructure configurations work, especially when you realize how certificates are becoming an ever more important part of your average Windows data center. Now, in this environment where I've got these servers that are distributing out certificates, so this is my issuing CA here. And in our case, it's also the root CA, but we'll call this our single CA. This is our CA. And when a CA actually issues a certificate, the certificate is nothing more than a series of letters and numbers. Those letters and numbers exist in a file. And that file, cryptographically, is what is used to authenticate a host, to help the host validate that it is who it is, or to also encrypt data. Now, when you end up issuing these little files, so I've got my little file here. This little file here with its content is there to, again, to prove that the server is who it says it is. But sometimes maybe you should lose a server or decommission a server, or maybe some server gets stolen, or maybe this certificate is used for a user and this user leaves the company. Oh no, he's left the company. Well, when that happens, it becomes necessary for us to expire this certificate at some period of time prior to the certificate's actual encoded expiry date. So I need to get rid of this certificate so this user can't end up proving that they're a member of our company when they're not actually anymore, or the server is not actually a workable server. One of the ways in which we do that is by publishing what's called a CRIL, or a certificate revocation list. And in order to publish the CRIL, we use what is called a CRIL distribution point. Now, I love this because it is a perfect example of what we used to call a multi-level acronym, because a certificate revocation list is the list of those certs that have been removed over here. And the CRIL distribution point is the second layer of the acronym. So CRLCDP. That CRIL distribution point is literally a location on a web server. It's a location in Active Directory. It's a location on a file server that contains this list of those certs that are no longer valid. And it's really important to have, because you don't want this little bad guy, or or masked bad guy down here, to have a certificate that he shouldn't be using. No, we want to knock him out of the network as fast as possible. Maybe we fired him. Maybe we fired his desktop as well. CRILs and CRIL distribution points allow us to do that. There are a couple of rules with CAs as far as administrative role separation you got to be aware of. There are a couple of rules out there, and there's one very important note about administrative role separation. So pay attention as it comes around, because you can actually accidentally screw yourself whenever you're building one of these CAs. I want to talk very quickly about backup and recovery, because there is a command line tool that you should be aware of. In fact, there's a couple of command line tools you should be aware of. And then also there is this thing called an online responder, or an OCSP. The online responder is a mechanism that allows people, users, computers to essentially get access to the contents of the CRIL. Now, if you can imagine a really large organization where you got lots and lots and lots of these certificates, and potentially lots and lots and lots of certificates that have been revoked over a period of time, downloading that long certificate revocation list can really decrease the performance of just needing to authenticate to a web server, or needing to authenticate a user. Well, an online responder is a mechanism that can actually respond, literally, to an incoming user or an incoming desktop when they need to find out if their certificate is valid or not. The process of using an online responder greatly increases the performance of checking to see if a certificate is valid or not. And so as the size of your organization gets large, as the number of certificates you've actually released gets large, this becomes very important because, well, you can just speed up things. I'll show you the simple process for implementing an online responder here in this nugget. So certificates, again, really, remarkably simple process, but if you start digging around online, like I said, there's just so much content that it can be hard to figure out where to start. So let's spend some time here in this nugget actually going through the implementation of a very basic certificate services infrastructure. I've got a server here, ca.company.pri, right here. And ca.company.pri is just your basic server. It's right out of the box. It's here in this domain. I've got a single IP address associated with it. There's really nothing else that I've done to it other than just to build it and get it on the domain. Now remember, there are two different types of certificate servers that we can put into place. Or actually, one could argue there are four. There are root servers. There are issuing servers. We are going to create one that is kind of both. Then there are also enterprise servers, and there are standalone servers. The most important difference here being that an enterprise server integrates with your already existing Active Directory. A standalone server does not, and that's most of what you should know. If you are building a CA that will predominantly be delivering out certificates for Windows machines that are in a domain, more often than not, the issuing CA should be an enterprise CA, not one that's standalone. In most situations, the standalone CA is the root CA. And again, all of this is content that go look at that other series, those couple of nuggets, for a better and deeper explanation of what they are. Here in the Add Roles and Features wizard, I'm going to show you that we just install ADCS here. ADCS has, down here at the bottom, 6 different role services that we could potentially implement. If you played with ADCS in previous versions, the one of these that you're probably most familiar with is the Certification Authority Web Enrollment. What web enrollment is it's that web page that you can go to request certificates and then to fulfill those requests. For now, I'm actually not going to install this because I don't want to show it to you just yet. This web enrollment can also work with the web service in order to fulfill requests and do all of the everyday management of certificates. But these are the two that you're probably most familiar with. The web service can also work with a policy web service so that non-domain joined machines can validate whether or not certificates are meeting whatever policies. Because you're going to create policies just like group policies, but they're going to be certificate services policies. And this policy web service provides a way for those non-domain joined machines to validate that the certificates you're creating meet your own policy. You can do the same thing down here for network devices. If you've got switches and routers and other kinds of network devices that for some reason or another need to participate in a certificate services infrastructure like a PKI, well, this is the way in which you can actually make that happen. We are going to install the online responder, which as you can see requires a web server in order to do its job, because that online responder is literally a web server itself, or it sits on top of IIS services itself. So we're going to install just the basics of the certification authority and the online responder here, and then accept all the role services and click the install button here to go about adding this. So let me pause things while I go through the install here. When we come back, we'll go through that initial configuration of our enterprise certificate authority. And we're back. So actually, I shouldn't have hit the finish button here, so you could see that indeed we completed the installation. But you'll notice up here that after we do complete that installation, we need to configure ADCS on this destination server. So just like with every one of these role installations, we got to go through the install and then the post-install configuration. Couple of pretty basic things we've got to do here is identify, well, what role services do we intend to install? If we want to do online responder, web enrollment, or a standalone, we need to belong to the local admins group. To do other things, we need to belong to the enterprise admins group. So some of these cert services pieces are going to require some pretty elevated permissions for us to do. Now, the point here is that doing this, especially in enterprise certification authority, doing this is something that generally is going to work for the forest. You kind of put these things together for your forest so that you have one that everybody can use. That's why you can see down here that actually building an enterprise certification authority as opposed to a standalone requires you to be a member of the enterprise admins group. I'm going to click next here, and we are going to configure both the CA and the online responder. And in doing this, we're going to have to set up just some of the initial policies that are associated with the CA itself. First of which is for us to identify what kind of CA we want this to be. Again, enterprise is Active Directory integrated, standalone is not. I'm going to choose an enterprise here because I want to make use of the ability to store certificates in Active Directory, to store some of the key recovery agents, which is a mechanism to restore keys that are lost. I want to store those in Active Directory. I also want to distribute some of these root certificates in Active Directory as well, or using Active Directory as well, specifically group policy. So I'll choose next here, and I can identify whether this is going to be a root or a subordinate CA. In situations like this one, where we're only going to have one CA and we're not going to have a CA hierarchy, I need to install a root CA. Now, if I were to have multiple CAs, like a root CA followed by a policy CA followed by an issuing CA, well, then the two below would end up being subordinates. I'll choose a root CA here because we're going to have a single root CA. And in the situation where we're creating a brand new root CA for the forest, we're not going to have an existing private key. If I were to have had a previous CA and I wanted to create another one, I could do that by exporting out private keys from the old CA and importing them in here to this new CA. That's a process by which I can migrate from perhaps from an old machine to a new machine, or from one operating system to another. But because this is the first CA in the forest, I will have to create a new private key. I have to, for that, then identify what the options will be, the cryptographic options will be for creating those keys. And much of the level of detail here is perhaps out of scope for this exam. If you have requirements that are coming to you from your security organization or from regulatory compliance, those may change which of the cryptographic providers you may use, what the key length is, and what the hash algorithm will be for those keys. A longer key length here corresponds to a much more difficult process to hack that key, to break that key, but also more computational requirements in order to make use of the key. So the default here at 2048 is a good kind of round number for us to get started with. Certain organizations that have high security requirements may ask you to increase the key length size just so that it makes it more difficult for you to break into those keys, or to use a different hashing mechanism for it. Down here about allowing administrator action when the private key is accessed. If you want to make sure that you're part of any kind of private key access on that CA, you can check this box here. I do need to identify what the name of this CA is going to be. The name of the CA right here will be company-computer name, which is in my case is CA-CA. So that's the common name that you'll need to be aware of anytime you plan on interfacing with this CA. You'll find out also that when certificates get released, get published by the CA, that this is the name by which those certificates will get published by. So this is the location of that CA here in your Active Directory environment. Then here is where I define what the validity period is going to be for the CA's key. Now what this is essentially saying is how long of a period of time should this CA be active before I need to go through a process to actually revalidate the certification authority itself. Now, in a perfect world where you would never have to worry about your CA getting stolen, you could change this validity period to something enormous, like 25 years long. But the problem is that you want to keep these certificates down to a manageable level and force yourself to go through a revalidation period to ensure that if at any point someone should happen to slip in and perhaps, grab a key or inadvertently steal a key or purposely steal a key, that you have the ability to at least shunt things off after a period of time. Remember, you might not be around in this company for a full 25 years. And so at the 5-year mark, the CA is essentially no longer going to be valid, which means that some administrator somewhere has to go through a process of revalidating the CA and then all the keys that are associated with it. 5 years is a good common period of time. It's in fact the default. The most important thing you have to recognize here is that any keys that you issue from this CA cannot exist for a longer period than the CA's validation period. So if you end up creating keys here, they can't be longer than 5 years in length. Or a year later, they can't be longer than 4 years in length. The keys that you create will never be able to exceed the validity period for the certificates that are being used. So you'll never create a key that goes beyond 2019. I'll leave it at 5 years here for now, and the same database locations. This is just built-in databases here. We're not using any kind of SQL database for our CA database, and choose to configure. This will go through the process of configuring that CA. Now you'll notice we didn't do any configuration for the online responder yet because we've got to do that inside of the certification authority console. So we're not going to really deal with too much of that pre-configuration here at this point. One of the things that we have to do before we get that far is actually to get the certification authority online. Now this is the certification authority console here, and it is the first of 2 different consoles that we'll be working with. The first one here it will be working with in this nugget. We'll talk about the second one, the certificates console, in the next nugget. So the idea here is that we've got kind of a role separation between the people who are managing the issuing of CA certificates, the revocation of certificates, and all the everyday activities of dealing with releasing new certificates and then grabbing them back whenever they're no longer necessary. On the other hand, we also have those people who may be managing the templates. And it's here where people can get a little bit confused because there is actually a certificates console. And if you click here under Manage, you can see that Certificate Templates console. But then you also see this Certificate Templates node here in the Certification Authority console. Now I'll get more into this into the next nugget, but I want you to be aware of that these are the templates that are currently available in issuing certificates. So out of the box, we are already we have the ability to issue web server certificates, computer certificates, user certificates, and so on. But later on, if we decide we want to, we can go about creating new templates, starting with these as sort of the template for the template, and then issuing those for other purposes. Okay, so hold that in your brain for just a second because it's going to become important here in a minute when we start dealing with the OCSP. Let's talk about a couple of the things that we have to do, or that we probably should do, in order to get this CA up and operational. Now, here under properties, you'll see a whole bunch of just different tabs for the different configurations you may lay into place whenever you're building your CA. You can have different policy and exit modules here, different enrollment agents if you want. We'll talk more about those later. I have the ability to edit which items that I want to audit, for example. And we'll talk also about key recovery agents so that you have the ability to restore people's keys if they happen to lose their certificates. Now, one of the things I want to show you here is under the Security tab, because like everything in Windows, we have to have some way for us to determine which users should have what privileges to do what things. Now, by default, the enterprise admins and domain admins have the ability to issue and manage certificates and also manage the CA itself. And you can add in additional people here if you want. Even the local administrators have that ability as well. For the exam, you should be aware of a special configuration called administrative role separation. That is, I don't see it implemented in, the only place I see this implemented is in very complex environments with large implementations that tend to be under certain regulatory requirements. In the typical Windows world, if you're an administrator, you pretty much have access to everything, right? You can perform all the actions that are necessary to do your job. Well, in the regulatory defined CA environment, it is a best practice to implement what is called administrative role separation, which means that the CA administrator may not be able to deal with templates and vice versa. So being a CA admin doesn't necessarily always get you full access to do whatever you want. And if I can put the right, let's see here. I can put the right URL in here. Maybe we can actually take a look at it. I want to show you this website here, which is here on TechNet. It's called Implement Role-Based Administration. And although it deals with Server 2008 R2, it's still relevant to what we're talking about here in 2012 R2. The way in which you implement the roles is by adjusting the security permissions on the server. It's really non-obvious in terms of how you do this. So the security permission manage CA is the one that we saw just back here. So manage CA. Same thing with issue and manage certificates is down here for issue and manage certificates. The backup operator has the security permission, which is defined completely elsewhere. This is a right that you assign in local rights assessment. Same thing with auditor and enrollees. So there's no really good way for you to define what these roles are except digging really deeply into the operating system in order to do this. Now again, out of the box, by default, the admins can do whatever they want. But there is the ability to turn on what is called administrative role separation, which says that if you're an admin in one thing, if you're responsible for one of these different roles, you cannot be responsible for any of the other ones. The way in which you enable that is through an elevated command prompt. And if I bring one up here, an elevated command prompt with the command is certutil setreg ca / role separation enabled and then 1. If you run this and then restart the CA services, be very careful because an administrator can only be assigned one of these roles, which means that if you're an admin, you're not going to be able to manage certificates. You're not going to be able to issue certificates. You're not going to be able to do backups. You're not going to be able to do auditing. Now, some organizations, again, have the requirement that you do this separation. If so, you turn that on. But for the most of us, I would not really deal with that because it's entirely possible for you to lock yourself out of certain abilities to do things by turning it on. So, okay, back to more interesting stuff. Let me bring back up this so we can see where we're at. So we've got our CA installed, and we've talked a bit about the role separation, how to deal with roles as well. Let me talk for a bit about the CRIL distribution points, the CDPs, because this is something that can be fundamentally useful for you, particularly if you end up having machines that are non-domain joined. Right out of the box, your certificate revocation list is available to any of your domain joined machines because it's been configured to do so. But occasionally you might have machines that are coming in from elsewhere, and you want to make sure that you've got some way for them to be able to check those certificates that have been revoked for one reason or another. Let me come back up here to our certificate, to our CA, and under the extensions dialog box here, the extensions tab, you'll see we have our CDP, our Creo distribution point. By default, we are publishing a copy of the CRIL to C Windows System 32 cert SRV cert enroll, which if I bring up Explorer here, you'll find that C Windows System 32 cert SRV cert enroll, there is the copy of the CRIL. There's also a CRT file up here. We'll talk about that in a second, but this is really the CRIL. And if I take a look at it here in Notepad, you'll see there's nothing really interesting about it. It's not human readable. This is what any of our incoming clients are going to look to in order to determine whether or not the certificate they're seeing is actually valid or not. Now, a couple of the checkboxes are particularly important here. When I'm publishing to a file-based location or to an LDAP-based location, this is Active Directory, actually a folder in Active Directory. Any of these that are available, you'll see that publish CRILs to this location and also publish Delta CRILs to this location are both checked. This means that there's actually some process by which your CA copies this file to this location. In the case of LDAP, it's copying the contents of the file to the location as well. So your domain join clients can query Active Directory for those certificate revocation lists. In the case of this HTTP location down here, you'll notice that we can't actually publish the CRIL to that location. And the reason for that is actually it's somewhat difficult to actually kind of figure out why this behaves in the way that it does. But the reason for this is that the way you go about actually publishing a CRIL, if you need to go to a non-domain joined machine, is that you need to publish the CRIL through a file-based mechanism. So I can literally come in here and click in, I don't know, C:/CRL, for example, and then give it a file name, mycril.crl. I need to publish it to this location and then create a second CDP entry, a second CDP location that is a web-based entry that points to the file that I just published. Okay, now that sounds really kind of ridiculous, but that's the way that you end up accomplishing this if you need to publish the CRIL to some secondary location. Let's assume, for example, that I want to create a secondary location to publish the CRIL to. Okay, I'm just going to copy it here to this local machine, and then I'm going to create an HTTP virtual directory in IIS in order to support pointing to that file that I just created. Now, when you create these, you'll notice that there's the ability to create them with all of these variables. So CA name, server DNS name, CRIL name suffix. The only point here is that you need to make sure that whatever you end up publishing through the file-based approach equals whatever you end up wanting to acquire or wanting to get to via the HTTP approach. The default is to publish it with the file name of CA name, CRIL name suffix, and Delta CRIL allowed. So let's publish here. Let's create a location called, I don't know, C:/myCRL, and then I'm going to call it CA name, then CRIL name suffix down here, and then Delta CRIL allowed.crl is the name of the file. Okay, bam. That adds that as one of the available locations to publish to. I'm going to go ahead and then also instruct the CA to publish that CRIL information to that location. I then need to actually create the folder here in my machine. So here's my CRL, and oops, I need to come back here and then create this with the appropriate security so that we can actually publish it. So I'm going to do CA $ as the computer name here and choose OK, and that should give me the permissions, I believe, to be able to publish it here to this location. All right, so if I hit apply and OK, that will stop and restart Active Directory services, and then I can come over here to publish my list of revoked certificates. I'm going to publish a new CRIL, so this contains the entire revocation list. And if I've done everything correctly, I should see the list here in my CRL. Yeah, there you go. So now I have these two files that I've created. I now need to be able to make or to engender access to these files using IIS. Let's do that by actually creating an IIS virtual directory that points to this location. Let me come down here to my default website, and that was why we don't need that because I actually created that earlier. Let's create a virtual directory here called myCRL to the physical path of myCRL, the place that I just created right there. I'm going to connect with pass-through authentications. And if I choose the test settings button, you're pretty much always going to get this little yellow dot here. I wouldn't sweat this at all. That's kind of what I was testing a while ago. So this essentially says that it can't verify access, but just make sure that you have access so that it can read whatever's necessary. IIS needs to have read permissions here in order to be able to access the information. So that's the MyCRL location. Now I need to come back over here to my company and create a second HTTP-based CRIL location. So http:// and then server DNS name, just like you see here, / myCRL / and then now the file name, which will be CA name, CRIL name, suffix, and so on and so forth. So CA name, CRIL name, suffix, and then delta CRIL allowed right there, and terminate it with a .crl extension, .crl. In the case of this second item, I'm not actually going to publish it, but instead I'm going to tell any certificates that I end up creating later on to go ahead and include inside the certificate that the location where the incoming client needs to go to find out if that certificate is actually relevant or not is this location, this website here. So if I include it here, I include it here, this now ends up doing everything that's necessary in order for me to create a secondary CRIL distribution point. Again, honestly, probably a test question here. And if I just republish here just to make sure, yes, no error messages. So we should be able to then access that location here via the web. In fact, let me come over here. Let's just test to see if we can actually download the CRIL. If I go to http://c.company.pri and then MyCRL, I should be able to see, not that obviously, I should be able to see the name of the CRIL here, which if I do a little trick here, I should be able to then download the CRIL. So yes, I will be able to now download the CRIL from this location. All right, so that's the process we need to know in order to do certificate revocation. The next thing we want to talk about has to do with backup and recovery. So obviously, whenever we have this machine up and running, we're preparing ourselves for the issuing of certificates. We have the revocation piece in place. I want to be able to back up the whole thing, right? Because once this thing is in place, it's got to be there so that the certificates actually work. Two things you have to know. The first is here under all tasks, that there is a backup and a recover CA wizard that you can apply. If you're going to back things up, make sure that you back up the private key, the CA database, and the certificate database and database log. That's what's going to be necessary in order for you to even be able to restore this CA. You can, when you get done, if you have to actually go through the CA process, you can choose the restore CA if you need to. Now, you'll have to stop Active Directory, or you'll have to stop the services in order to do that. But this is the process by which you can go through restoring the CA. I will also point you to the fact that there are a couple of command lines that you probably should know if you need to be able to configure that backup and recovery. And I think I can access both of them through PowerShell. The first one, the old school command, is cert util, U-T-I-L, with the question mark. And what you're looking for here is to back up either the backup, the database, back up the key, and then restore, restore DB, and restore key. So cert util is one of the tools that you would use to accomplish that. In Windows Server 2012 are two new commandlets have been made available in order to accomplish the same thing. The first one is backup CA role service, and then the other one is restore CA role service. So this is the command you would use in order to back up the CA role, and then restore CA role service is going to be the one you'll use to restore the CA. Just be aware of what those are, because those are the ones in R2 that presumably replace the cert util command in order for accomplishing that. Now we do have one more topic that we have to talk about here in this nugget, and that is actually setting up the online responder. Now imagine for just a minute that you are in a large organization and you have set up your CA here, perhaps even a CA hierarchy with multiple ones that link to each other, and you've got some PKI, some private key infrastructure, public key infrastructure that you set up. And so you've got all these people that have got their desktops out here. You've got a bunch of happy little users that are also out here. You've even got some servers. And over time, 5 years down the road, 6, 10 years down the road, you've found yourself having to actually revoke a variety of these certificates as people come and go. Well, this whole krill right here, the certificate revocation list, is going to continuously get longer and longer and longer as the numbers of these certificates end up getting revoked for one reason or another. And consequently, the process to actually figure out if a certificate is actually valid or not can begin to become a kind of an arduous process, because you just got to go through and download that entire list and figure out if that certificate is valid or not. Well, one way in which you can kind of get around this and keep the performance there when you're checking for certificate revocation is involved by setting up what's called an online responder, or essentially a little piece, this CA here, that says, you know what, I'm going to download the krill myself. And then if you end up asking me any questions, well, I have an optimized piece of software code that knows all the answers to the questions here, and I can respond back to you faster than you having to download the entire krill all by yourself. As you recall, we've already installed the OCSP as part of our original installation. Let's now go through the process of getting it up and running. First thing we have to do before we even start getting into the actual configuration of OCSP is to recognize that there is a specific kind of OCSP certificate that we need to make available to our certificate server. You'll notice that, as I said before, these are the list of certificate templates that are available to be issued, meaning that I could possibly create a certificate based off of these templates now because the certificate server is up and running. In order to be able to deploy an OCSP certificate, I need to actually make that certificate available for use. The way that I do that involves coming here into the certificate templates console and finding this template here called OCSP response signing and rename it to something that makes sense for you. So let's change the names on this to OCSP response signing and then company CA. Okay, so that's the template name there, so it's at least a little more intelligently named. I'm then going to pop into this certificate and actually change the security on the certificate so that my online responder has the ability to issue certificates based off of this template. Okay, so that will be CA $, which is my computer name here. Make sure I plug in here for computers, and OK, and OK. He needs the ability to read and enroll. Again, this is kind of getting ahead for what our next nugget is about, but the process here essentially is allowing the computer, CA, to be able to enroll a certificate based off of this template. Now you'll see why here in just a second, because in order to be able to configure the CA, I have to be able to have that certificate template available. Let's finish the process by coming here to New and New Certificate Template to Issue, and then associating it with this OCSP response signing certificate. Okay, so now this is a certificate template that I could use to generate certificates. All right, last step of the process comes over here to Online Responder, and then we need to create what's called a revocation configuration, which essentially is the connection between the responder and the CA that contains the krill information we want to offload. So I'll choose Next here, and we'll call this my revocation configuration, for lack of a better name. Choose Next, and what CA do we want to associate the responder with, which is the only one we've created so far, our company CA. Then which signing certificate template do we want to use for actually signing the results? So when I'm sending information back to a machine, I want to make sure that those results are actually authenticated. This is the template that I'm going to use for accomplishing that process. Choose Next again, and then identify with the revocation provider that I'm interested in using. In this case, where do I want to get the krill from? I can do that from Active Directory. I could do that also from the website that we created earlier in this nugget. We'll put it in the Active Directory for now, just because that was the one that was created right out of the box. If I want to associate it with Delta krills as well, if I have a separate location for Delta krills, I could assign those here as well. If I choose OK and finish, after a second or so, we should have a successful replication or revocation configuration, and our server ca.company.pri should be successfully now responding to any of the clients on the network. We do actually have to, you know what, I think I lied to you. I told you this was the last step, but there is one more step here. We do actually have to let the clients know to look for this online responder. And so in order to do that, we got one little tiny step here back in properties. Under extensions, we need to create another location, but this is not a critical distribution point. This is an authority information access. This is the mechanism by which the clients can actually identify, hey, check it out, I need to go to an online responder to see where, to ask my questions about certificate revocation. Just like with CDPs, there are some AIAs available right out of the box, but we need to create another one to be used for online responding. And if you recall, back here in IIS, there was this OCSP virtual directory that got created. That got created when we added the online responder, that role service, right in the beginning of this nugget. All we have to do now is just to simply point to this location, because this location should include the information that we need once we end up deploying it. So let me go back here and create a website to http:// and then the server DNS name, and then slash OCSP, essentially to point myself to that location. I need to include that in the AIA extension of issued certificates and also include in the OCSP extension. So this will essentially tell the certificates that they need to go to this location in order to access whatever web services are responding on their behalf. So gotta have that in order to complete the process, restart Active Directory certificate services, and now this responder, the one that we have here, will do everything based off of the revocation configuration that we've set up over here. Now, what have we talked about in this nugget? We've gone through the kind of the initial configuration of a CA, and admittedly, some of these things are kind of optional. I mean, if you're dealing just with clients that are already in your domain that have access to Active Directory, you probably don't need to set up a separate CRIL distribution point. That part is already configured on your behalf. If you're not dealing with other people that need to, manage some portion of your CA infrastructure, you don't need to set up administrative role separation. If your CRIL is not going to get very large, you don't even need to set up an online responder. If you're just not creating lots and lots and lots of certificates that could potentially get revoked, that's something that's unnecessary as well. You probably are going to need to do a CA backup and recovery, but most important, as we talked about in this nugget, you do need to have that certificate authority set up and running if you plan on managing your own certificates. Coming up next, we're going to take what we've learned here in this nugget and actually go through the management of certificates and certificate templates. This is really the fun part as it relates to Active Directory certificate services. You're going to get to see how you can create and adjust the templates themselves and then issue them so that you can create your own public key infrastructure and save yourself potentially a whole lot of money on those public certs. That's the topic for our next nugget. So until then, I hope this has been informative for you, and I'd like to thank you for viewing.